Good morning, friends. We are learning our subject, that is data mining 3160714. In that, we are learning our chapter 3, that is concept description and association rule mining. So, in last lecture, what we have studied, that was the hash base item set counting, right? Now, we want to learn further. So, DHP, that is direct hashing with efficient pruning. Fine. It reduces the number of candidates. What we are doing is we are trying to improve the Apriori algorithm. That is, we are trying to remove limitations of Apriori algorithm. For that, either we can reduce the time or we can reduce the number of scan of database, isn't it? Okay, so this is what we are learning. Now in that DHP hashing we have already seen, right? We have already seen. So now what we want to know here, that is a k item set whose corresponding hashing bucket count is below the threshold cannot be frequent. So what do we say about that? For example, candidates are A, B, C, D, E. Hash entries are say AB, AD, AE, BD, BE, DE. Frequent one-side item set, they are say A, B, D and E. AB is not a candidate two-item set if the sum of count of AB, AD, AE is below support threshold. Are you getting this? See, for the items, that is we can say A, B, C, D, E. We do have A, B, D, E as frequent. So hash entries according to the database transactions, we can say they are AB, AD, AE, BD, BED. Right? These are the items available right here in the hash entries. Now, what is the condition for pruning? That this AB, which is available here, what do we say is AB is not a candidate two item set if the sum of count of all the items available for that particular hash bucket is what is say any number. Here we can say it is 35, right? Now, if the total count of all these three items is below the threshold value, whichever is given for this example, suppose for this example, the threshold value given is 50 and this sum, that is whatever is the count of AB, AD and AE, the count total is say 35, it is less than that of the support threshold and that is 50. Then we can say AB cannot be the frequent item set. Okay. So that is the way we are doing pruning. Fine. Now, the next method which we want to know is transaction reduction method. Next method is transaction reduction method. We want to reduce the transaction. Till now what we were doing was we were trying to reduce the data by considering few conditions, right? We were trying to have something by which we do not have to traverse the transactions again and again. This is what we were doing. Now this method says what? That reduce the transaction. So we do not have to scan more times. No, we are saying that, say, thousands of transactions we are having, in that we have reduced the data. So we can say that our algorithm will faster. Yes. Okay. So that's what we want to do here. Transaction that does not contain any frequent k item sets cannot contain any frequent k plus 1 item sets. Such transaction can be removed from further consideration. What do we say is the transaction that does not contain any frequent item set cannot contain any frequent k plus 1 item set. Just now, whichever is not having frequent items, they cannot generate the next frequent item set. That is what the meaning of this particular algorithm, right? Such transaction can be removed from further consideration. So let us see the example we can be clear with. And here also I have written the example in the way that you should write in your exam in this manner only, right? Okay, you can say, ma'am, yellow color, how to put it? So you can use any other color, but you can show the things properly. Fine? Okay. So let me show you. The transaction table is given to us. That is with the TID, transaction ID and items. 100, 200, 300, 400, ACD, BCE, ABCE and BE. Right? Now, what to do? Let's see. The items are A, B, C, D, E, right? The items are A, B, C, D, E. What are the transactions? They are, say, T1, T2, T3, T4. You can say the ID is given as 100, 200, 300, 400. Use that. See, you can use it, or otherwise you can name it as T1, T2, T3, T4, right? It is up to you. Now, what we do? Let us see the transaction. That is the first transaction, A, C, D. Now, what we want to do is, wherever the letter A is there, we'll put 1 in that particular column for that transaction. If that item is not there, for example, here A is there. So, for A of transaction 1, we'll put 1. B, is it there? No, it is not there. So for transaction T1, for B, we'll put the value 0. For C, is it there? Yes, it is there. C. So for transaction T1, we'll put it as 1. For D, it is there. Yes. So for transaction T1, we'll put the value 1. E is there? No, it is not there. So let us put 0 for transaction T1 and E, right? So value according to that is 0. Now we have to put the same way for all the transactions. Let me show you once again so you can have the idea for transaction T2. Okay. So B, C, E. Okay. A is there? No, it is not there. So for transaction T2, for A, we'll put the value 0. For B, C, we do have the item for T2 transaction. So for T2 transaction, for B and C, we'll put 1, 1. Then what about D? D available here for transaction 2? No, it is not available. So what will we do? We'll put 0 for that. For E, what to do? We'll put 1, right? Because it is available here. Fine. So let us say that it is 1. Fine. Okay. Same way for A, B, C, E in transaction T3, we'll put T3A, T3B, T3C and T3E as 1, and for D we'll put 0. Same way for T4, B and E is there. So for B and for E, let us put 1 and others 0. Fine. Now what to do? We have to do the summation row wise and column wise. We have to do the summation. Here you can see sum. Here also sum is there, right? So what we do is we do the summation row wise as well as we do the summation column wise. Fine. Here 1, 2, 3. So 3 is there. What is minimum support given? Minimum support given is 2, right? It is given as 2. So now what do we check is this sum. If it is greater than or equal to minimum support, fine, right? If it is greater than or equal to minimum support, it is fine. Fine means what? We'll see a bit later. For this T2 transaction, 1, 2, 3, that is 3 greater than minimum support. 1, 2, 3, 4. 4 is also greater than minimum support. For this T4 transaction, 0, 1, 0, 0, 1. So total is 2. That is equal to minimum support, right? What do we say about the frequent items or item sets? We used to say that wherever the count, whatever count we consider, support count, for that, if it is greater than or equal to minimum support, we consider that item or item set as frequent, isn't it? So that's what we are trying to do here. That is, whatever sum we found that is greater than or equal to minimum support. Fine. That's what we are checking here. Now, vertically what we are doing is, say 2. 2 is equal to what? Minimum support, right? 3 is greater than minimum support. 3 is greater than minimum support. 1 is less than minimum support. And 3 is greater than minimum support. You can say, what is this? 2, 3, 3, 1, 3. It is the total of this column, right? For A, 1, 0, 1. So 1 plus 1 is 2. For B, it is 1 plus 1 plus 1 is 3, right? That way, this is 1, 2, 3. Here only 1 is there. Fine. Here 1, 2, 3 is there, right? What do we say about this transaction reduction method is transaction that does not contain any frequent K item sets can not contain any frequent K plus 1 item sets. Okay. So what to do? Where the total vertical, no, horizontal, no, then you can have wherever you have the total which is less than minimum support will remove that particular thing, right? Column, row, whatever, right? We'll remove that from further processing because this is not frequent. When it itself is not frequent, it cannot generate the frequent item sets. Fine. So that's what is the concept of transaction reduction method. So now we have seen that for this particular column is not having minimum support which is greater than or equal to the minimum support. Fine. So what to do? Remove that from further processing, right? Its support is less than minimum support, right? So remove that. Let us proceed further. So D column will remove, right? I have shown it highlighted. You can see it very nicely, isn't it? Let us go to next. Remaining one. After removing D column, who doesn't satisfy the minimum support? Let us check it out. Now we do have A, B, C, E. D is removed, right? D is removed. Now let us do the same thing again. That is, for each and every transaction, we will put 1 where the item is there. Otherwise, we'll put 0. Fine. So, ACD. So, put 1 for A, 1 for C, and 1 for D. Where it is? C column is not there, right? D column is not there. So we do not have to put 1 for this particular D. Why it is not there? Because we have removed. Why we have removed? Because that column was having total count or sum as less than minimum support. Fine? Okay. So D is not there. Okay, fine. Do the total horizontally, that is row wise. 1 plus 1, that is 2, right? 1 plus 1, that is 2. Fine. Whether it is greater than or equal to minimum support or not, this is 2, right? It is equal to minimum support. Fine. It is equal to minimum support. Fine. Let's see further. B, C, E. So for B, C and E we are putting 1. What is the horizontal total? That is 1 plus 1 plus 1, that is 3, which is greater than minimum support. Fine. What about T3? A, B, C, E. For each and every item we have put 1. When we do total horizontally, that is row wise, we are getting it as 4, which is greater than minimum support. Let us go to T4. For that, A is there? No, only B and E are there. So, for B1, for E1. So, what is the total row wise? That is the 2, and that is equal to minimum support. Fine. So, what do we say? What do we say about all this? For row wise, we can say that their count, I mean their summation is greater than or equal to minimum support. Fine. So no issue for row. Let us check it out for column also. So let us do the summation vertically. 1 plus 1 is 2. 1 plus 1 plus 1 is 3. 1 plus 1 plus 1 is 3. 1 plus 1 plus 1 is 3. For all these columns A, B, C, E. For all of them, the sum is greater than or equal to the minimum support. So, any transaction is removed. Vertically, that is row wise transaction is removed. No. Row wise, no. Vertically, that is column wise, no, because everywhere the sum is greater than or equal to the minimum support. Fine. So what do we say is frequent items are A, B, C, E, right? Now, what do we want? Two-item set generation. Isn't it? What we actually want is, we do not want to consider only single item. We need to consider two-item set, then three-item set, isn't it? Okay, so let us proceed further. From the frequent item set, who are they? A, B, C, E. So for two-item set generation, what items we can consider? They are the combination of this 4, that is A, B, C and E, isn't it? So which combinations we can make? Let's see. AB, AC, AE, BC, BE, CE, right? So from the frequent item set L1, we will be able to generate two item set as AB, AC, AE, BC, BEC. Right? So this is what we are putting in the columns now. The transaction IDs that were what we have considered T1, T2, T3, T4. Fine. Now, according to the items in the transactions, we'll be putting 0 and 1. Fine. Let's see. AB, is it there? No, it is not there. So, 0. AC is there? Yes, it is there. So, for AC 1, AE, not there. BC, not there. BE, not there. CE, not there. Right? So, 0, 0, 0. Do this summation row wise. For this particular row, we'll be having 1, which is less than minimum support. So, we'll remove that from further processing. Fine. Okay. Now, for T2, BCE. For AB, no. AC, no. AE, no. BC, yes. So 1. BE, 1. CE, 1. So row wise total 1 plus 1 plus 1, and that is equal to 3, which is greater than minimum support. T3 transaction A, B, C, E. So for AB, yes. AC, yes. AE, yes. BC, yes. BE, yes. CE, yes. Ooh. For all the two items set, T3 transaction is having 1. So what is the total? Row wise, 1 plus 1 plus 1 plus 1 plus 1 plus 1. 6 times, right? So we can say we are getting it as 6, which is also greater than minimum support. Now for T4 transaction, we are having only B and E. AB? No. AC? No. AE? No. BC? No. BE? Yes. So for that only we are putting 1, and for all others we are putting 0. Now what is the total? Now this total we are having, that is, we can say, is 1, right? This total is actually having 1 summation. So what we say is we need to remove this transaction also, isn't it? We should remove this transaction also. So how we can do that? Let us put it like this, and we can say let us highlight this using this yellow color, right? Oh, this one, field color, right? We should highlight that. Okay. So this was the border color, right? Okay. So we can say it is now for this particular transaction also we are having minimum support. Is it equal to 1? It is equal to 2, right? It is equal to 2. So here it is less than minimum support, right? It is less than minimum support. Fine. So we'll remove that from further processing, right? So what are the frequent items? A, B? No. Vertically also we have to do the summation, no? This is 1. So less than minimum support, remove that. For this AC, what do we say? It is 1 plus 1, 2. That is equal to minimum support. What about this? It is 1. So it is, which is less than minimum support. So remove that from further processing. 1 plus 1, 2. That is equal to minimum support. So consider that this is 3. So which is greater than minimum support. Here also 3, which is greater than minimum support. Fine. You should write it this way only. Then otherwise you will say, ma'am, you haven't written, so we'll also not write, right? No, not that way. You should have that. Fine. greater than minimum support, right? Now see, I'm keeping it like this. So when I'm adding it this way, you yourself also remember. No, you have to do that, right? Okay. So now what to do? A, B column we should remove, isn't it? Because it is not having the sum which is greater than or equal to minimum support, or otherwise we can say its sum is less than minimum support, right? Okay, so remove that from further processing. What about AC? Should we remove? No, vertically we should not. What about AE? Should we remove that? Yes, we have to remove that. So we should remove AB and AE, isn't it? AB and AE, right? Okay. And what about the transactions we should remove? That is T1 and T2, right? T1 and T2? No. It is T4, right? T1 and T4 we should remove from further processing. And what are the frequent item sets? That is A, C, B, C, B, E, and C, E, right? AC, BC, BE, and CE, right? That's what we have listed here. Fine. Okay. So now let us proceed further. We should now consider only T2 and T3, right? T2 and T3. T4 is not there. Let us remove that. Isn't it? Because what we have considered is this is not there. We should remove that from further processing. Fine. Okay. So now what to do? T1, T2, T3, T4, they are there, right? Now what? Now what to consider? AC, BC, BE, CE. This is what we have already considered, right? AC, BC, BE, and CE, right? AC for what? T2 transaction. Do we have that? Do we have that? AC? No. BC is there? Yes. BE is there? Yes. CE is there? Yes. The same table, right? This table only, just we have removed the transaction T1 and T4 and removed AB and AE, right? That's what we are putting here, right? For T3, what we can say is, what was there? AC is there, BC is there, BE is there, and C is there, right? So that's what we are putting here, right? For the L2, right? We are putting it in this table so we can have the idea for further processing. Okay, right? So whatever was that, that's only I have put here. We are not doing any processing, right? We have just removed and showing the table. Fine. Now what should we do is we should go ahead with three item set, isn't it? What is written here after removal remaining ones, right? You can say, ma'am, here 1 plus 1 plus 1, this is 3. Okay, fine, but this is 1 plus 1 plus 1 plus 1. So it is 4 only. So why are you writing it as 6? See, whatever is remaining one, that only I am putting here. And whatever we got from here, that only represented, right? So the after removal, whatever the table we are able to see, that only I'm representing. Okay. Not generating next level item set in this one. Okay. To next level, we can do that. Remaining ones, we can see it summarized, right? Okay. So now for three item set generation, we can have B, C, E. Why B, C, E? Here we are having A, C, D. Shouldn't we consider that? Should we consider that? Do we have T1 transaction here? No, it is not there. So I should consider in the next level when it is not crossing the transaction reduction methods condition, then T1 and T4 we have already removed, right? So we should not consider them. Yeah. Here also T4 we should not consider, right? T4 we should not consider because we are only having T2 and T3, right? Okay, so that's what we have put here. Now let us check it out. T2. No need to check for T1, right? No need to check for this T4. We will only have T2, T3. So we'll check for that only. Okay. T2, BCE. Okay. For T3, here ABC. Can it be frequent? ABC. ABC means all these subsets must be frequent. So AB is there, node is not there, isn't it? We know that a priori property says that ABC can be frequent only if all of its subsets are frequent, right? So AB, AC, BC all must be frequent, which is not the case here. AB is not frequent in the L2. So in L3, it cannot be there, isn't it? So ABC cannot be there. BCE, can it be there? Let us check the subsets. BC, BE and CE, right? Let's check it out. BC is that? Yes. BE is that? Yes. CE is that? Yes. Right? So, what do we say is BCE can be frequent. Right? So, let us put that here. What about the next item? Can we have ACE? ACE means AC, CE and AE must be frequent and that should be available in L2. So AC is there. Okay. Then CE is also there. Yes. But AE, is it there? No, it is not there. So ACE cannot be frequent. Right? Okay. So here we'll only have one column, that is BCE, right? Now what to do? T2 and T3. Should we consider again T1 and T4? No, that we have removed, right? In the past, or you can say last level item set. Which item set? Frequent item set, right? Okay. So in L2, it is not there. So we'll not consider them in the L3. Fine. So let us check it out here. T2, BC, BCE. Yes, it is there. So put it as 1. Here it is that BCE. Yes. So put it 1. What about this sum here? That is, you can say 2 and that is equal to minimum support. Fine. So now what do we say is it is crossing the minimum support, or you can say that it is greater than or equal to minimum support. And so for three item set generation, only BCE is frequent, right? Got it? Here the link is also there. You can see that. Now, the next method which we want to know is sampling for frequent patterns. What do we want to do is sampling for frequent patterns, right? Let's see what is there in the method. Select a sample of original database. Mine frequent patterns within sample using a priori. Sample. Take this sample from the original database. Mine frequent patterns within sample using a priori. Scan database once to verify frequent item sets found in sample. Only borders of closer or frequent patterns are checked. For example, check ABCD instead of AB, AC, etc. Scan database again to find missed frequent patterns. Who has given this? That is H. Toivonen, who has given the sampling large databases for association rules. That person has given this algorithm. Fine. For large databases. Okay. Now, dynamic item set counting. What is that? It reduces the number of passes made over the data while keeping the number of item sets which are counted in any pass relatively low. What it says? It reduces the number of passes. Okay. What it does? Keeping the number of item sets which are counted in any pass relatively low. Right? The technique can add new candidate item sets at any marked start point of the database during the scanning of the database. Fine. Item sets are dynamically added and deleted as transactions are read. It relies on the fact that for an item set to be frequent, all of its subsets must be frequent. So, we only examine those item sets whose subsets are all frequent. Fine. Algorithm stops after every M transactions to add more item sets. For train analogy, what is that? There are stations every M transactions. The passengers are item sets. Item sets can get on at any stop as long as they get off at the same stop in the next pass around the database, right? Very simple is, you can say train example is there, train analogy we can say. Stations are there, right? There are stations every M transactions. The passengers are the item sets. The item sets get on at any stop as long as they get off at the same stop in the next pass around the database, right? From when we are traveling through the train, people are coming in and people are going out, right? For whenever the stations are coming, right? So that's what is the train analogy for this. Only item sets on the train are counted when they occur in transactions. At the very beginning, we can start counting one item sets. At the first station, we can start counting some of the two item sets. At the second station, we can start counting three item sets as well as any more two item sets that cannot be counted and so on. So what do we do? At the very beginning, we start counting one item set at first station and some of the two item sets when second station comes. At that time, we can start counting two item sets, whichever are there, or you can say whichever were remaining, and three item sets counting will start. Fine. Now, what is that? Dynamic item set counting algorithm. That's what we are learning. Fine. Okay. Item sets are marked in four different ways. One is they are counted. Let's check it out. Solid box. DIC. What is DIC? Department in charge? No. Dynamic item set counting. Right? So DIC, solid box. Confirmed. Frequent item set. An item set we have finished counting and exceeds the minimum support threshold, that is minimum support. Fine. Solid circle. See, these are the symbols we are going to use for the example, right? There will be putting the symbols and we'll proceed further, right? Whenever we say that solid box is there, that means it confirmed that the frequent item set is there. If we say solid circle is there, what do we say is it has confirmed in frequent item set. When solid box is there, it confirms frequent. When we say solid circle, it confirms infrequent item set, right? We have finished counting and it is below minimum support. So, hope you understand the difference. Solid box means confirmed frequent. Solid circle means confirmed not frequent, right? Or infrequent. Okay. Dashed box. Test box. What is that? Suspected frequent item. It can be frequent. Okay. But will it be? That depends. An item set we are still counting that exceeds minimum support. Fine. Dash circle. That is DIC dash circle suspected infrequent item set. See, one thing you should understand is when it is box, it is frequent and circle means infrequent. One thing is box means frequent, circle means infrequent, right? Now, if it is solid box, it is confirmed frequent. Solid means confirmed, right? So solid box means confirmed frequent. Solid means confirmed and circle means infrequent, right? Okay, so solid circle means confirmed infrequent. Dash box. Dash box. Dash means suspected, right? Box. Box means frequent, right? So suspected frequent item set. What about dash circle? Dash means suspected. Circle means infrequent, right? So dash circle means suspected infrequent item set, right? Now using this, we'll be having the example, right? We'll be having the example. Mark the empty item set. Mark the empty item set. Nothing is there in it with solid square or solid box, we can say, right? Solid square or solid box. So solid box means solid means confirm and box means solid means confirmed and box means frequent, right? So solid square. Wherever empty item set is there, make it as solid box or solid square. That means it is frequent, right? Mark all the one item set with dash circle. Dash means suspected and circle means infrequent, right? Okay. Leave all other item sets unmarked. While any dashed item sets remaining, read M transactions If we reach the end of the transaction file, continue from the beginning. Let's say four transactions are there. So T1, T2, T3, T4. Now start again. Again T1, T2, T3, T4, right? Okay. For each transaction, increment the respective counters for the item sets that appear in the transaction and are marked with dashes. Okay. If a dash circles count exceeds minimum support, dash means suspected, circle means infrequent, right? If its count exceeds minimum support, turn it into a dash square. Dashed, suspected, square, frequent, right? Suspected, frequent. Dash circle, that means suspected, infrequent. Dash square means suspected, frequent, right? Okay. If any immediate superset of it has all its subset as solid, or dash squares, add a new counter for it and make it a dash circle, right? Once a dashed item set has been counted through all the transactions, make it solid and stop counting it, right? So what do we have? We are having item set lattice. An item set lattice contains all the possible item sets for a transaction database. Each item set in the lattice points to all of its supersets. When represented graphically, uh, uh, an item set lattice can help us to understand the concept behind the DIC algorithm. Fine. So for that, we'll have the example that we will see in the next class. That's all for today.